Okay, let's talk a little bit about the types of weather data that are common to collect for different either citizen science projects or just activities that you would do with your students. So there's a lot of different things you can collect. So let's just call this data to collect over here and write down that probably the most common thing that comes to mind is temperature. That's something that we all feel and we all think about every day when we think about the weather, and it's pretty easy to measure the temperature. You don't need anything fancy, you just need a thermometer. So temperature is probably the number one piece of weather data that's easy for kids to collect and think about. Another thing is rainfall. And I'll show you the rain gauge that I use, and that's part of a network of rain gauges that people use to collect rainfall data and submit it online and then look at all the rainfall data from around the country or around the world even. Another common one related to that, and I'll put it underneath, is snowfall, because when we collect rainfall data in the winter, we collect snowfall data instead and report it as part of the same network. So rainfall and snowfall kind of go together. Another commonly collected piece of data that goes with most home weather stations and school weather stations is wind direction and speed. So wind speed and direction, I'll put. And this is something that most weather stations collect. If we look at my home weather station, you'll see an anemometer up there, which is the thing that records the wind speed, and also a wind vane, which records the wind direction. And then there are all kinds of other pieces of weather data, weather-related data that some weather stations collect as well. Things like humidity, and these can be in terms of relative humidity or absolute humidity. Lots of different related things there. In addition to humidity, station pressure, and this is air pressure. The air pressure at the station location is a common one as well. If the pressure is dropping, then maybe we have a low pressure weather system around us, or if the pressure is high, then maybe we have a high pressure weather system. Right now, with all this hot weather we have in Colorado, we have usually very stable, high pressure air masses around, so the station pressure is usually pretty high. And then other things that are of interest, especially right now with our current fires, are air quality measurements. And you've probably seen a lot of this in the news. Right now our air quality in Colorado is fairly unhealthy. We have a lot of particulate matter, and these are usually reported in terms of the size of the particulate. So right now we're really concerned with the 2.5 micron particle size, which is really small. It's a heck of a lot smaller than the diameter of a human hair. A human hair is about 70 microns in diameter, so 2.5 microns is a very small fraction of a human hair diameter. These are really fine particles in the air that contribute to air pollution. But things like 2.5 micron particles, nitrogen dioxide, surface level ozone, there are a lot of different things that go into air quality and a lot of different air quality metrics. So I'll show you a screenshot or something of a system called Purple Air, which is a great website where you can go to look at different air quality metrics to see how healthy or unhealthy it is. So in short, there's a ton of different data that can be collected as part of your studies on weather with kids, or that can just be accessed as well, not even collected. Things that are easy for kids to collect on site, if you have a weather station at your school or even at their homes, are things like temperature and rainfall, and then maybe wind speed and direction, and some of these others depending on how sophisticated the weather station is. So let's talk about now what we would do with that data to support some of the scientific and engineering practices as outlined in the next generation science standards. And I want to think about this in terms of science notebooks, which is the other thing that we're talking about in class this week. So if we go over here and we think about our science notebooking, what kinds of things could we do in our science notebooks to support the use of scientific and engineering practices? Well, obviously we could record data and observations in the notebooks. So, recording observations and data. We could write down what the temperature is every day at noon, or we could write down what the wind speed is, or how much rainfall we get every day as part of the CocoRoss network. I'll show you that one. It's actually very cool and very easy for kids to participate in. But what about the specific practices? A lot of the practices that you will look at in class today and that I want you to think about focusing on are things that are really what scientists do and what science is all about. And everybody can access these practices and engage with them. And so some of the practices that we can really focus on in science notebooking are things like constructing explanations. Apologies for my handwriting. But constructing explanations are where we might try to make sense of the data. So there's no rain right now. How might we make sense of that? Well, we don't have any moisture right now because we have these high pressure stable air masses, and so the only rain we might get is from a late afternoon thunderstorm that develops. But if there's not enough moisture in the atmosphere, we won't get those thunderstorms. Explanations are kids' ways of making sense, scientists' ways of making sense of the data. And that's something we can teach our kids to do and that they can write in their notebooks. Another thing we could encourage here is developing and using models. Models are representations of how things work. So we could help kids understand from a modeling perspective how to make sense of the water cycle, for example. The water cycle is a model of how water evaporates or transpires off the surface of the earth, condenses in the atmosphere, and then falls again as precipitation. So describing those models and putting together those models in a science notebook is a great way to encourage the support of the explanations that they construct. So developing and using models is a big one. And then there's a practice called mathematical and computational thinking. That's a great way to look at trends in data over time. So thinking about if you make a graph of temperature every day at noon over the course of 2 months, you might see a pattern and you might try to make sense of that pattern and why that's the case. So I'm just going to abbreviate that. Math and computational thinking. These are just a few of the scientific and engineering practices, science and engineering practices that are outlined in NGSS. There are 8 of them. And there are others that could apply in science notebooks. These are just the ones that come to mind right away when we think about science notebooking and weather. And the one thing I really want to encourage you to use notebooks for is to get your kids writing. Weather's a great subject to write about. Think of all the descriptive writing and creative writing we can do about weather, and that you've probably seen before. When we read something that's describing a cold, blustery day in which you wouldn't want to go outside, that's a really creative way to think about linking the science and the writing together. And that's kind of stuff you can do in your notebooks, in science notebooks as well. Don't think of them as only a place for strict science and engineering practices. Think of them as a place for creative writing too. So I really want to emphasize that you can use science notebooks as a place to encourage writing. We can get our kids doing a lot of writing, whether it's creative writing or scientific writing, in the science notebooks. Okay, so that's an overview of weather data that we could collect if we're engaging in science practices and some of the affordances of using science notebooks. Now we'll go take a look at some of the different ways we can collect weather data physically with weather stations, and also online by accessing data that's already been collected for us. There's a home weather station. A lot of schools have weather stations already installed on them. If the school doesn't have it, it's likely that some neighborhood nearby has a weather station on a house that's already installed that you can access the data from the internet. This particular one's got a wind sensor on top. You can see that's an anemometer, is the spinny thing which measures wind speed, and a wind vane for direction. Also temperature, rainfall, humidity sensor. So there's a lot of personal weather stations and school weather stations that are online that you can get data from. This is a rain gauge that's part of a network of rain gauges called the CocoRoss network, which I'll discuss in other parts of the video. And this is a manual rain gauge. They're much more accurate than the electronic ones that people deploy at their houses. Again, a lot of schools have rain gauges like this, and every day you take the rainfall reading and report it to the network and share the data so you can access rainfall and snowfall data for lots of places around the world. So this is a good example of a citizen science project that a lot of people are involved in. But schools that you're at may already have a rain gauge just like this installed, or they often will give them to a school to install them. So this is a great project for kids in checking the rain every day and making measurements and submitting data to be recorded. Okay, let's talk about some places on the web where you can find some weather data and also engage in some science practices of collecting and reporting data. One really great place to start is Weather Underground. It's just at wonderground.com. It's a whole network of home weather stations that is feeding data into the internet, and you can see in real time what the weather conditions are and even look at the histories for those stations. So for example, here's my weather station, which I showed you in the video outside, reporting to Weather Underground. It updated 12 seconds ago. It's currently 89.4 degrees Fahrenheit. Winds are not blowing at all out of the south was the last thing. And there's other data here as well that we talked about: station pressure, solar radiation, and UV as well. No rainfall today. I have no webcam on here, but you can see, and there's some nice graphs of what the temperature has done. Looks like the lowest temperature we had today was around 64 Fahrenheit. So there's a wealth of data here. And if you use the map function as well, you can find other stations that have weather data that are reporting to the internet as well. So we could scroll over here to this particular station in North Glen and see it's 90 degrees there right now. And at 91.2, I guess, it takes us to the data for that station. So Wonderground is a great place to find local weather data in real time and look at that. And there might even be a weather station at your school. Another great weather network is the Ambient Weather Network. That's at ambientweather.net. And so folks that have ambient weather stations also report in this pretty nice web interface, where you can click on a station. Again, this one's mine, and you can see the temperature, the dew point, and the actual feels like temperature, which we didn't talk about, but that would be related to either wind chill or heat index, depending on the conditions. And you can see the specifics of that by clicking View Dashboard, and you get all kinds of there's even my indoor temperature and humidity are on the dashboard, but you get all kinds of weather data there as well. So there's a number of places where you can get weather data. Rainfall is one of the things that kids can easily engage in, and there are a bunch of resources here at the CocoRoss network. CocoRoss stands for the Community Collaborative Rain, Hail, and Snow Network, and it started at Colorado State University as a place to get people to input their daily rain and snowfall so scientists could keep track of that and build better climate models. They have a bunch of resources for teachers. They even have programs where they'll give away those rain gauges like the one I showed you outside to schools. And then every day you can make your rainfall measurement and submit it to the CocoRoss network so scientists can use it. It's a great example of a citizen science project. You can see just today they've received over 10,000 reports that people submit.
And it's really easy to do. There's a phone app as well. I haven't submitted my report yet today. We didn't have any rainfall, but even the zeros count. So I'll go ahead and do that now. If I just click on my account here, I can see the details for my station, the station number I have, where it's located, things like that. And then I'm going to enter my new daily precipitation report. And you can see this is the kind of thing that kids would do. The date and time they made the observation, they would enter in the total rain or melted snow. It's easy today because it's 0, so I just leave it at 0. Any notes on the observation, like it was really windy, or the rain gauge overflowed, or we didn't get a good measurement because there was a bug in the rain gauge too. You can report snowfall, and if you have more details about when it started raining and ended raining. So I'll submit my data for the day. It's just a 0. And you can see that here's my recent last week's data. It's been a bunch of zeros, although one day we had some nice rain. But that's a really good place for kids to get involved. So rainfall collection, and they could keep notes of that in their science notebook. And then finally, something that's really relevant to us now is our air quality index. Here's a nice network of air quality indicators, and something you could keep track of in your class as well, or have kids check this. It's called purpleair.com. And Purple Air is a network of air quality sensors that people deploy and feed into this whole network so you can see what the air quality is. So one that's fairly close to me over here, if I click on it, it says 110. And that'll tell me that today the 10-minute average is this 110 value, which is in a range where members of sensitive groups may experience health effects if they're exposed for 24 hours. So it's not great. And we can see a graph over time. It's certainly gotten worse. And this is because of all the wildfires that are close to us. So you can get a good sense of what the air quality is by looking at a network like the Purple Air network, where we'll show you all the sensor data and give you some information about it as well. It'll show you down here sort of where those ranges are. Some places are really poor right now, in the 300 and 400s out in California. It's especially bad. So the takeaway here is there are a lot of places where you can collect weather data on the web, or look at it, or kids can, and even contribute to reporting, like the CoCoRaHS network for rain and snowfall. It's a great example of getting kids involved in making observations, writing about it, and constructing explanations and models. It's a great opportunity to do some science notebooking too. So especially if you're in grade 3, where the weather and climate standards really apply, consider using some of these web-based resources and some weather observation together with science notebooking to encourage students to engage themselves in the science and engineering practices. Okay, let's chat about that in Slack, and let me know if you have any questions.